Good morning, ladies and gentlemen. This is 1.26 Solving Quadratic Equations Part 2, Solving by Isolating. Not all quadratic equations can be solved by factoring, so this is a different way that we're going to solve. We need to solve by isolating. Eliminate the terms from one side of the equation. Put equation in vertex form by completing the square. I'll show you guys how to do that. And isolate x. In our first example here, we need to solve by isolating x. So the first thing we do is our step from up here. Oops. The first thing we do is solve from our step from up here. First we're going to move the 32 over. So we'll end up with 2 bracket x plus 1 squared equals positive 32. Okay. Next line, we're going to get rid of the 2, and we do that by dividing both sides by 2. Because if you divide this by 2, this cancels out here. So when you divide this by 2, you'll get 16. So we'll have x plus 1 squared equals 16. And this is where things get a little hairy, just because the way that I've seen some teachers teach it is different than the way that I learned it when I was in high school. And the way that I would go about this in high school is different than I would do it now. But the way I did it in high school was basically, once I got to this point, whatever was in the brackets, I would say let z, oops, let's fix that. Eraser, let's erase that. For some reason, my pen likes to mess with me. Let z equal whatever's in the brackets there. So it'd be x plus 1. Then you would end up with z squared equals 16. How do you get rid of the squared? Well, because we have z squared here. That's a z, not a 2. Now let me put a line through it just to make it a little bit clearer that that's a z. Z squared equals 16. Well, if you square root both sides, you'll get what z's equal to. Then you have z equals 4 plus minus 4. That's key, plus minus 4. Because negative 4 squared will also give you 16, and positive 4 squared will give you 16. Both of those work as the root of 16. That's why we need to include that. Now, we need to sub back in what was in the brackets, and we get x plus 1 equals plus minus 4. Which means that we have x equals two different things. Because we're going to move the 1 over, and that means it's going to be negative 1. So we could have positive 4 minus 1, or negative 4 minus 1, because it's plus minus 4. Which means that x is equal to 3 or negative 5. Those are our two solutions there. So in this case, we couldn't solve by factoring. We were just solving by isolating. The optional part would be right here and here. I would say those are optional. You don't have to say let z equal that. You could just square root this up here. So you could just square root it. And that would give you x plus 1. Because x plus 1 in brackets squared, if you take the square root of that, it's just x plus 1. Okay. Moving on to the next example. Sometimes we'll have irrational roots. You guys should remember what irrational numbers are, like root 2. We can't turn that into a whole number. We just leave it as root 2. That's an irrational number. Because you can't reason with it. That's why it's irrational. No, you can't write it as a finite amount of decimals. That's what our irrational numbers are. Okay, so here we have solve x minus 2 squared minus 3 equals 0. Set it up the same way. We're going to move the 3 over. We have x minus 2 squared equals positive 3. Now here's where it's optional. I'm going to use a different color this time. If I was thinking ahead, I probably should have done that earlier. Let's not use that. Let's use red. because red would be optional. And I would say let z equal x minus 2, because then I have z squared equals 3. Then I have to actually take the square root of both sides. But 3 doesn't square root very nicely. It's an irrational number. So we have z equals plus minus root 3. Because negative root 3 squared is still positive root 3. Okay, and that ends the optional segment of that. And what this ends up looking like, because you sub x minus 2 back in for z, you'll have x minus 2 equals plus minus root 3. So x minus 2 plus minus root 3. That means we need to move the 2 over, and we're stuck with x equals 2 plus root 3 and 2 minus root 3. Or you could write it as 2 plus minus root 3. This signifies that there's two different roots or solutions. So this would be your final answer here. You could leave it as the top one or the bottom one. Either way, I would give you full marks. I like to write out both like I did the line before this. But the bottom line is a little bit more concise. You can do that if you would like. Okay, let's go on to the next page. And I am back. I did reveal some of the notes just because the computer written text is a lot neater than I could write on my tablet. This way it just keeps things simple and keeps us moving along at a decent pace. So solve using the quadratic formula. Solve using the quadratic formula. You need to simplify the equation so that ax squared plus bx plus c equals 0. Once you get your equation in standard form, you can start using a, b, and c in your quadratic formula. You just sub in the a, b, and c values into the quadratic formula. In this case, it's x equals negative b. Be very careful of that. That's often where the mistakes begin. Plus and minus, remember plus minus, the root of b squared minus 4ac all over 2a. I don't really have a fancy trick for memorizing this. My math teacher always taught us to write it out and then say it repeatedly. And for some reason that worked in high school, but I forgot it when I got to university. So that was the method that I would use. In addition to that, right before a test, if I knew I was going to use it in that course, if I used it in that course at all, I would make sure I would write out that formula on a scrap piece of paper before I went into the exam and say it out loud, just so that when I got in there, it was fresh in my mind. And that's the strategy I use to memorize things, because as you guys know, my memory is awful. Okay, moving on to the first example, because this formula doesn't make a whole lot of sense. Here, in our first example on the left, our a value is 1, right? Because it's 1x squared. Minus 9 goes in for b, or negative 9, and then negative 22 for c. You sub all those values into your formula. And you have x plus minus root negative 9 squared minus 4 times a, which is 1, times c, which is negative 22, all over 2a, which is 2 times 1. And we're going to do a little bit of calculating. The way that you evaluate this is you actually evaluate what's under the square root first. So I'm going to have you evaluate what's under the square root. And I'm left with 9 plus minus square root of something all over 2. What goes under the square root? 9 squared minus 4 times 1 times negative 22. If you got 169, you are correct. And what's nice about this is it actually rounds, or it roots to a whole number. So we're stuck with 9 plus minus 13 over 2. So our two roots will be 9 plus 13 over 2 and 9 minus 13 over 2. So what are our two roots? X equals, or our two solutions here, it should be x equals what? If you said x equals 11 and negative 2, you are correct. Notice in this case, we could have actually just used our factoring method. We could have just factored. Just because it's very simple and straightforward, it would have worked out very, very nice, and we could have said 11 and 2. However, quadratic formula will work for even the equations that can factor nicely. So our next example, we actually look at an example that doesn't factor very nicely, because if you took out a factor of the a value here, which is 6, so if you took out a factor of 6, you'd end up with 1/6 over here and 15 over 6, which doesn't factor very nicely. What adds to 1/6 and multiplies to 15 over 6? You can do it in theory. It is possible to do, however, it is a bit of a pain. That's why we use our quadratic formula. All right, so we sub in our a value, or our b value, negative b. In this case, b is negative 1, so it becomes positive 1. So b is negative 1, it becomes positive 1, plus minus square root b squared, which is negative 1. Remember, b is negative 1 squared, minus our 4ac. So 4 minus 4 times a, which is 6, times c, which is negative 15, all over 2a, which is 2 times 6. There we go. Okay, again, same idea. Evaluate what's under the square root sign first. We're going to say x equals our 1 value plus minus square root of something all over 12. And if you, or I'll give you a minute to evaluate what's under the square root sign. If you said it is 361 under the square root sign, you are correct. Now you can actually evaluate this. It rounds it down to a nice whole number. We're left with 1 plus minus 19 over 12. So 1 plus 19 over 12, that'd be 20 over 12 is one of our roots. So we have 20 over 12. And then we also have 1 minus 19 over 12, which is just negative 18 over 12. Then you need to reduce these down. So we have x is equal to 5 over 3 and negative 3 over 2. Because those are just the reduction of those fractions. And that's all it is. Oh, and our therefore statement. I forgot my therefore symbol there. Therefore, x equals 5 over 3 and negative 3 over 2. Okay. Let's move on to another quadratic formula example that has an irrational answer. And I kind of like the irrational answers because it's a little less writing. Okay. I'm going to pause for a second. And in example 4 here, I did reveal the first line just because the computer's written text is a lot neater than I could do with the stylus. So here we have x squared minus 4x plus 1 equals 0. We don't have to rearrange the formula because we have our standard form written out nice and neat, equal to 0. Now we have x equals our negative b, which is positive 4 because b is negative 4, plus minus square root of b squared, which is negative 4, minus 4ac. So it's minus 4 times a, which is 1, times c, which is 1, all over 2a, which is 2 times 1, because a is 1. Our next step is to evaluate what's under the square root sign. So I'm going to give you time to figure that out. I have 4 plus minus square root of something all over 2, because 2 times 1 is 2. Okay, what is 4 squared minus 4 times 1 times 1? Sorry, negative 4 squared. Subtract 4 times 1 times 1. If you said 12, you are correct. And we can actually reduce this fraction now, or this irrational number. In 12, well, root 12, let's do an aside here. Root 12 is just equal to root 4, root 3, right? Because 4 times 3 gives us 12, so root 12 is equal to root 4 times root 3. Root 4 is just 2, right? So it's 2 root 3. So then we're stuck with 4 plus minus 2 root 3. That's really 2 times root 3. If you punch in root 12 into your calculator, and then you punch in 2 times root 3, you should get the same decimal. I'm going to need a little bit more room, so I'm going to go back up to the top here. And we can take out a factor of 2 of both, because 4 divided by 2 is just 2, and then 2 root 3 divided by 2 is just root 3. So we end up with 2 plus minus root 3. So x equals 2 plus minus root 3, and that is your final answer right there, actually. You could write it out one more step if you want. You don't have to write it this way. I usually like doing this just because I don't want to forget about both signs or both roots if there's 2. But you can leave it as plus minus root 3, and that is fine. Okay, that's it for this assignment. As you're working through the work, make sure you keep writing out that quadratic formula. That's going to help you out a lot. And good luck with the assignment. If you have questions, feel free to ask me.